Hi, and welcome to the last section of the course, ES6 and external D3.js libraries. In this final section, we're going to look into a couple of usages of D3, not directly related to the main D3 provided APIs. Let's start with the first video, using D3 with ES6. In this video, we're going to explore D3 usage from ES6. When developing ES6, you have to take into account the browsers you're targeting. Most modern browsers have great support for the ES6 standard, but pretty much the one subject that is barely supported is the module support. So for now, we have to translate our ES6 code into ES5, so it can be loaded directly into any browser. This is often called transpiling. For a complete overview of the features of ES6, you may visit this link. Before we look at the interesting features, we first have to create a setup, which can transpile ES6 code to normal JavaScript, which can run in any browser. For this, we'll create a simple Webpack setup, available at this GitHub link. With Webpack, we can transpile our ES6 code and package all the dependencies. In the directory ES6, you can find all the configuration which is used to support the transpiling and bundling of our code. Let me append a symbols example and write parts of it to ES6 to show you some of the features of D3 in combination with ES6. First task is importing modules. The D3 distribution is divided into multiple modules. Without ES6, we could add the individual libraries as dependencies to the top of our HTML file like this, then use it from our JavaScript file using the D3 namespace. With ES6 and modules, we don't have to add the individual D3 files to the index.html file, but can include them in our JavaScript file using an import. Now we can use the functions directly without using the D3 prefix we'd normally need to use. Our code will then change to this. If you want to import the complete D3 library, you can do this as well using imports. An additional advantage of importing D3 is that it makes it easier for your editor to present you with the correct completions. For instance, if we import D3 scale like this, we can very easily see and access all the different scales. With this approach, you can use D3 in the same way as shown. Since all the functions are bound to the D3 name, when you're using imports, it is also much easier to divide your own application into multiple smaller files that each expose some functionality. More information on module support in ES6 can be found here. Moving on to arrow functions and method shorthand. A very nice feature of ES6 is the way we can define functions using arrows. Normally, in JavaScript, and especially with D3, we define functions like this. Here we define two functions to set the value of the fill and the D attribute. With arrow functions, we can change the code in this manner. Here we show two examples of the arrow function. For the fill attribute, we return the result of the color D name function. This is a special case, where we only have a single expression. We could have done the same for the D attribute, but an alternative approach is writing out the body between parentheses. You do have to add a return statement in that case. As you can imagine, this approach can really clean up your code a lot for all the various D3 callbacks, where you want to have the value of an attribute to be based on the passed in data. One thing to keep in mind when using arrow functions are references to this. When you use this inside arrow functions, they use the same scope as the surrounding code. In D3, that can cause issues, since sometimes this is used to pass around information. For example, accessing the current node which is being processed. For instance, we set an attribute using these two calls. The first one is using the arrow notation, and the other one is using the standard notation. This is undefined for the arrow function, but defined for the normal function. In those scenarios, you still need a function to access the passed in this context. For functions, ES6 also provides a shorthand. This code defines two functions on the obj object with the names do something and do something else. Let's see block scope binding constructs. With ES6, you also get two new constructs for defining variables. In JavaScript, we already had var to assign a variable. However, var is function scoped, instead of scoped to the current block. With function scope, it doesn't matter where in the function you define the variable. You can use it everywhere in that function, even before you declared that variable. So this code is perfectly legal, since the var I declaration is pulled to the top of the function. This is kind of non-traditional behavior, and can lead to hard to find bugs. With ES6, we get the let and the const keywords. With let, we make sure that the variable is only used in the code block it is defined in, and const, which is also block scoped, allows us to define values that can't be redeclared. So the code in our example looks like this. Even though this doesn't make our code more concise to read, it does avoid a number of hard to catch bugs. The final feature of ES6, which we'll look at in relation to D3, is string interpolation. In D3, we often use the translate property to move a G to a specific position. Code to do this usually looks something like this. Conversely, with the arrow functions we saw earlier, it would look like this. With string interpolation, we can avoid having to use addition symbol to concatenate the strings and variables. This code will now appear like this. We add single backticks around the string we want to interpolate and reference the variable or expression by enclosing it in this manner. This was all about D3 and ES6.